Hey everyone, Mr. Delgado here. We're going to be covering this week's topic is going to be covering relations and functions. Our essential question is, how can I determine if a relation is a function? Now, this question is relatively easy, as long as you guys are focusing on, well, you have to know what a function is first off, and find out what a relation is, right? So a relation is a function that only has one output. So this is key, one output for every input. Okay, so our outputs are going to be our y's, right, from what we recall, and our input's going to be our x's. This can be determined by analyzing a table of ordered pairs or a graph. So it can be used on a table or a graph. Visually, it's much easier to identify it on a graph, and you guys will see why a little bit later on in our notes. So in a table of ordered pairs, the x or input value cannot repeat. It cannot repeat. When analyzing a graph, one may utilize the vertical line test. Now, I'll kind of go over that with you guys when we look at our graphs as our examples. So here's an example of a table, right? I always call it a T-chart. It's a table or a T-chart. Either one is fine. So if we're looking at the values or the relations between these ordered pairs, I'm going to rewrite them. So this is a 1, this is a 2, this one's a 2, 3, 4, 5, 6. You'll see that for every input, there's only one output, right? There's only one output. So here's my inputs, 1, 2, 3, 4, 5, 6, and each one has its own output, right? It's a different output. But if we're looking at this one, we have two inputs of the same number, right? So if we input a 1 here, so these are 1s and 1s, you'll notice that it gets two different outputs, even though the input is 1 on both of these. Okay? All right. So the domain is another way of saying x, and the range is another way of saying y. The domain of a relation is all of the input values of x. The range is the relation. The range of a relation is all the output values of y. So domain is x, range is y. Okay? So here we're looking at our vertical line test. This one I said is much easier to be able to identify whether a relation is a function or not. So what you do is, if you have your graph, so this is my line, right? This is my line. In order to check to see if this is a function or not, you can use like a straight edge, or you can use your pencil, and you kind of just want to guide your hand, like, so you're just going to be checking vertically if it ever crosses that axis or that line. It cannot cross that line more than once in order to be a function. Okay, so we're looking at a parabola right here. If we take a straight line, a vertical straight line, and we pass it through the graph, we'll see that it never passes it more than once, right? And that works for all of these, right? So these would be functions based off the vertical line test. Just visually, you can see that really easily. These are functions because of vertical line does not hit more than 1 point on the graph. However, these would not be functions, right? So I gave you guys an Edpuzzle video that you guys should watch, and it really goes pretty good into depth about how these would not work, right? I mean, visually you can see that it crosses at 2 points, here and here. Okay, so this would not be a function, right? And again, here's another one where it crosses at 2 points, here, and it does it actually multiple times, here and here, here and here, all kinds, right? So these are not functions, okay? Again, so those are good examples of non-function relations, all right? Please be sure to add questions in the margins, again, on this, and a summary using some of the key terms that we used in this video. I'm going to go ahead and move on to the next part. So this is function notation. Function notation is a way of writing equations using the function, okay? So I'm sure you guys are used to seeing equations written out this way, right? Where y equals 2x plus 4. Well, I'm going to go ahead and say this. The typical notation for a function is f of x, right? So it's read f of x. It is just a fancy way. I always say it's a fancy, like in math, we like to take simple subjects and make them complicated because that's what we do. And so just think about it this way, okay? F of x is a fancy way of saying y, okay? So if we have this equation, y equals 2x plus 4, the way we do it in function notation, which sounds super difficult and scary, is just make the y into f of x. Now, why is this important? Why would we even bother making it fancy? Well, because it makes it to where it's easy to input values into the function. So instead of saying, let's look at this example right here. Instead of saying, hey, find the value of y when x equals 2. So I would have to write all that out, right? Which is kind of a little tedious. I could say the same thing by saying f of 2. Just say find f of 2. And then you would, it's just faster, right? And so that's what we're looking at. So if we were to do that, we would just plug in the 2 where the x is at, and we would say, well, 2 times 2 equals 4, 4 plus 4 equals 8. So therefore, f of 2 equals 8, right? Or that would also be, y equals 8, right? Because of the f of x equals y. So when if we were going to write a pair, right? So my x and y value, right? When my x was input as 2, my output was y. And so that would be a point on that function of that graph, right? Similarly, you would got the same answer. It just takes a little bit longer to write in this format than it does in this one. All right, guys. Again, please make sure you guys write your summaries and add some questions into the margins. If you do have any questions on this, we will be covering this next week in class. All right, see you guys next time.